In this lecture, we are going to describe two types of monochromatic aberrations. We know that aberrations are the defect produced by the optical system or lenses. In monochromatic aberrations, we allow only a single wavelength or monochromatic radiations on our optical system or on our lens. Due to the due, uh, due to the passage at different points of the lenses, some incident rays passes from the marginal points and some are paraxial rays, and due to these different widths and different magnification of, of the object of the image, due to the thickness of different portions of the lenses, some sort of defects are produced in the image, and these defects are known as monochromatic aberrations. Today we are going to discuss two type of monochromatic aberrations. One is known as coma aberration, and second one which we are going to discuss today is astigmatism. In case of coma aberration, if the object point object is far away from the principal axis and giving incident radiations at different position of the lenses on the screen, we obtain not a single point image. We get different images at different point on the principal axis. The incident ray which is passing through the center of the lens will give a point image on the screen. Let us consider it is giving a point of image at any point P. Let us consider the one ray is, now we are indicating it by 2, and the another ray having the same separation from the midpoint. Let us consider the another ray is 2 dash. They will produce another image before this screen, and if the screen is placed at x and x dash position, we will find out that this image which is produced as at s is find in on the screen, we will obtain it like this. Similarly, if we considering that any ray at point 3 and having the same separation, there is a ray 3 dash below the pole of the lens, we will find out they will focus at any point. Let us consider this is T at any point T before the screen, and we will find out if the screen is placed at x and x dash, we will have a big circle or big image as compared to the rays as compared to the image produced by the rays 2 and 2 dash and so on. We will find out that with the point image at point P, we are getting some blurred, less intense images on the screen, and we will find out that this shape is like the shape of a comet. Hence, this type of aberration is known as coma aberration. The coma aberration is due to the reason that the object is far away from the principal axis and the rays coming from these objects or this source are away from the center or the pole of the lens. This coma aberration can be reduced with the help of two methods. One is with the help of the use of stops. By using stops, let us consider if we block the rays of this side and similarly from the downside, then we will have only the rays which are coming from the central part of the lens, and we will obtain a point image. With the help of the stops, we can reduce or eliminate coma aberration. And the second method by which we can remove the coma aberration is the use of aplantic lens. In case of aplantic lens, the lens should obey Abbey's sign condition according to the condition given by the optician known as Abbey. And according to the Abbey condition, mu1 h1 sine theta 1 should be equal to mu2 h2 sine theta 2, where mu1 is the refractive index of the lens from the object side and h1 is the height of the object from the principal axis, or we can say the size of the object above the principal axis. Theta 1 is the angle of inclination made by the different rays on the principal axis. Similarly, mu2 h2 sine theta 2 are representing the same terms from the image side. As we know that the coma aberration is due to the different magnification, or we can say that there is increase in magnification on the screen due to the different rays coming from the marginal part of our lens. If we change these magnification at a constant value, it means this circle is of same size as that of this, and if the size of all these circles are same, then we will get the same or the single image or a point image. It means the magnification, that is the size of the image divided by the size of the object, should be constant. And if we put this condition, we will obtain that for this condition sine theta 1 divided by sine theta 2, that the inclination made by the rays coming from the object side on the principal axis and the angle of inclination made by the image rays to the with the principal axis, find out to be constant. If this equation is satisfied by our lens, we will remove or eliminate or limit the coma aberration. And these type the lenses which define this condition, these lenses are known as aplantic lens. The second type of aberration which we are going to discuss here is the astigmatism. And in case of astigmatism, like coma aberration, the object is far away from the principal axis. Let us consider this is a convex lens and this is our principal axis, and the object is placed at point O and the light is coming from the point P. And we find out that the light coming from point P meets the lens at different points. Let us consider the light coming from point P meets the lens nearby at a point C and far by at a point D. This is the reason of the astigmatism abrasion. Due to the incident light inciding on different points of the lens, we will get different images on the screen. Let us consider the light from point P is moving the corner of the lens at point A, and another ray is coming at point B, and we know that these two rays will meet at point T, and we will get a point image. If we are not considering this part, we are only considering the marginal rays, and these marginal rays give us the primary image, that is a point image or a sharp image at any point T. But as we are seeing that the rays are coming at different points on the lens also, and if we are considering the point C and D, we will find out that these rays which are coming from C and D, they will meet at any point far away from T, and let us consider they are meeting at any point S. It means we are again getting a secondary image. And if we consider other rays which are meeting at different points on the lens, one is nearby the object and another is far away from the object, we will get different images in between the point T and S, and this is the defect which is known as astigmatism. In case of astigmatism, if we find out the space in between T and S and we randomly put different screens in between T and S, we will find out that on screen at point T we will get a horizontal image, and at if we move the screen from point T to S, the image will change into an ellipse such that the major axis is parallel to the principal axis. If we continue to move the screen towards the point S, we will find out a circle in between T and S, and the point is very nearby to T, and this is the intersecting points where we find out this circle. Let us consider we denote these two intersecting points, that is M and N. This is the position where we get the circle on the screen, and this distance is known as, or the circle is known as, the circle of least confusion. The circle of least confusion is find out at the point M and N. If we continue to move the screen towards S, we will find out that this circle will change into an ellipse, and now the ellipse major axis is no longer parallel to the principal axis. Now the major axis is perpendicular to the principal axis, and at point S, if the screen is put at point S, we will get a line which is perpendicular to the principal axis. Hence, in case of astigmatism aberration, we are getting different lines, and the lines are find out to be perpendicular to each other. This type of aberration or the defect produced is known as astigmatism. Astigmatism abrasion can be reduced with the help of, first, we can use some sort of combination of convex and concave lens. If we use a compound lens, which is a combination of convex and concave lens having opposite property or opposite astigmatism behavior, then we can remove astigmatism aberration. With the help of plano-convex lens also, we can remove the astigmatism aberration. And if we allow only the marginal lines to cross the lens, we will get a single image. Hence, with the help of stoppers also, if we stop the paraxial rays, we can only get the image at point T. So with the help of stops also, we can remove the astigmatism aberration.